Good morning. This is going to be for integrated 3, just for the worksheet that we got, solving systems of 3 equations. This is actually the exact same thing that I had in that long video that I posted earlier this week. So if you feel good about it, there's nothing new in this video. This is just me going through some more examples. If you want to see me do some more examples, I'm going to do the first 3 problems here. I'm going to do 1, 3, and 5. I wanted to say a couple things. One is I noticed some of these problems, like 29, 31, they have 4 equations and 4 variables. If you want to try stuff like that out, go for it. However, that is beyond the scope of this class. You're not going to be tested on anything like that. So I'm not going to do a bunch of videos on those because those are not required for this class. As far as doing these problems, I know they are time consuming. I know there's a lot of them, so obviously I do not expect you to have all of them done. I just expect you to do your best and work and see how far you can get. Okay, so that said, I'm going to go ahead and go through a few of these. It's just going to be more examples of stuff that you've already seen. Okay, so here's the first one. There wasn't a whole lot of space on the page, so I just went ahead, rewrote them down again, and I'm going to work through them over here on the side. All right, so this is problem number 1. Again, remember what we want to do. We want to eliminate a variable. So first thing I notice is if I'm looking at these top 2 equations, remember what we're looking at. This goes back to last Friday when we were talking about opposites. We've already got opposites, right? Because on the C, we've got a coefficient of +1, and here we've got a coefficient of -1. All right, so I can go ahead, I can take those first 2 equations, I'm going to copy them down, and I can go ahead and just add them together, and that is going to eliminate my C variable. All right, so think we're going to add these together. That's 3a. Negative 2b plus b is negative 1b. The c's cancel out. 5 minus 1 is 4. All right, so now I've got to use some other combination. I can use the top one with the bottom one, or I can use the bottom 2. And again, it doesn't matter which ones we use as long as we're going to have to do some multiplier, and we need to eliminate that same variable. We need to stay eliminating C. All right, well, here's what I notice is I can take this top equation, looking at that bottom one, and I'm actually really close to having opposites, right? Because that top one is a coefficient of 1. The bottom one is a coefficient of -2. So think, if I multiply that top one by 2, then I'm going to have a 2c on top and a -2c on the bottom, and then we're going to have opposites. All right, so let's do that. Let's go ahead and take this top equation here, and then think I'm multiplying it all the way through by 2 on both sides. So it's going to be a 2a minus 4b plus 2c equals 10. And then I'm going to take this bottom equation and rewrite it right here, because then when we add them together, we're eliminating that c variable. All right, so we've got 3a plus 3b minus 2c equals -4. All right, let's add these together. That's going to give us 5a minus b equals 6. All right, and there we go. So now we've got a couple equations. Right, we've got one right here, we've got one right here, and that makes it a lot easier because now we've got 2 equations with the same 2 variables. We've got an a and a b in each one. Okay, well, notice our b's, again, we're actually really close to having opposites. Right? So if I go ahead, I multiply either one of those equations by a -1 on both sides, then one of them is going to have a plus b, one of them is going to have a minus b, so then I can add them together and get rid of the b, and then we'll be able to solve for a. So let's do that. Again, it doesn't matter which one. I'll multiply this one. I'll multiply this one here by -1. All right, so that's going to become a -3a, a plus b, and a -4, right? I took this guy, multiplied it by -1. All right, and now I can just bring this one down and add them together. So I'm going to have a 5a minus b equals 6, and that's going to make 2a equals 2. Divide by 2 on both sides, and there we go. We've solved for a. All right, so let's go plug that back in. I'll plug it into this one here. So 5 times a, so 5 times 1 minus b equals 6. All right, so that's 5 minus b equals 6. And we can subtract 5 on both sides. So we'll get -b equals 1. And divide by -1. So b equals -1. All right, last step. We haven't solved for c yet, so we'll go back. plug into one of our original equations and solve for c. I'll just use this first one here again. It doesn't matter which one. I'm going to use the top one. So I have a, so that's 1, minus 2b. So minus 2b, which is negative 1, plus c equals 5. All right, let's solve for c. So we got 1. Negative 2 times negative 1 is a positive 2. So 1 plus 2 plus c equals 5. 1 plus 2 is 3. Subtract 3 on both sides, and we've got c equals 2. All right, there we go. There's one example. Next one, this is problem number 3. I just copied it and wrote it over here so we have space. One thing I want to point out, notice that on my z's, I crossed the z's. The reason I do that is because I see all the time students will mix up the z's with a 2. And just to make it a little bit more clear that this is a z and not a 2, I go ahead and cross the z's. I just think it helps a little bit. All right, one other thing I noticed is up until this point, all of our variables have been on the same side of our equation. Until right here, we've got a z on the other side, right? Usually we'd had x, y, z on the same side and then a number on there. So let's go ahead and just get it in that format. Whenever we've got letters on both sides, I just say, just move it over, all right? So the second one, imagine I am subtracting a z on both sides, all right? So that means on my left side, now I'm gonna have a minus z, all right? I'm gonna have a minus z, and then on my right side, that cancels out, right? So by subtracting that z on both sides, I moved it over to the left side of the equal sign. So now it's all on the same side. Okay, great. Now here, it actually, I can't really find a variable that's going to be any easier to eliminate than the others. Right? Because I've got a coefficient of 3 and then a couple 1s on my x's. Y's are all the same with a couple 1s and a 3. And then even the same thing on the z's. I got a -1, a -1, and a -3. So I actually don't think there's going to be really one that'll be any easier than the others. I'll just eliminate z, because why not? Just pick one. It doesn't matter which variable you eliminate, as long as you do the same one both times. All right, so I'm going to write my first equation down. I got 3x plus y minus c equals 11. And if I want to use these top two, right, because we're really close to opposites, I just need to multiply this guy by -1, right, because then I want to change that into a plus z, right, because then I'll have opposites. If I can make that into a plus z, then we'll have opposites, which is what we want. So let's multiply it through by -1. Okay, so this second equation will become -x minus 3y plus z equals -13. There we go. All right, so we'll end up with 2x minus 2y equals -2. All right, and then where are we going to go from here? I'll use the second and the third equation. I'm going to use these two now in blue for my next one. So, and again, we want to eliminate z because that's the one we just eliminated. So we got x plus 3y minus z equals 13. And we've got x plus y minus 3z equals 11. All right, so think about how we can get opposites, all right? So we want to turn that into a positive 3. So think about how can I go from -1 to positive 3? What do I need to multiply by? We need to multiply by -3. So let's go through the whole top equation and imagine I'm multiplying it by -3. All right, I'm going to multiply this whole thing by -3. All right, so what that does, if I multiply by -3, this x will become a -3x. 3y will become a -9y. Negative z will become a plus 3z. 13 multiplying by -3 becomes a -39. All right, now we're good to add these together. We're going to cancel out the z's now. So we got -2x minus 8y. The z's cancel as we wanted, equals negative. My brain's not working, -28. Okay, we've got a couple equations now. And look what we have. This is actually awesome, because look at this. We've already got opposites. We've got a 2x and a -2x. So that means we're already ready to go. We've got two equations, two variables, and we even have a pair of opposite coefficients here. So I can go ahead and write my red equation. I'm going to take this guy, right? I'm right under here, right? Because we're already ready to combine them because we've already got our opposites. So we've got 2x minus 2y equals -2. All right, so our x's are going to cancel. Negative 8 minus 2 is negative 10. Negative 28 minus 2 is negative 30. All right, let's divide that by negative 10, and you'll get y equals 3. Great, already solved for y. Let's go plug that back in and get x. I'll plug it in right here. So I have 2x minus 2y, but that's, instead of y, we're going to substitute 3, and then equals negative 2. All right, 2 times 3 is 6. And we'll add 6 to both sides and divide by 2. All right, last thing we're going to do, we're going to go back into one of our original equations and plug in both of these guys, and it's going to give us z. I'll just use this one that's already right here. So I've got x plus y minus 3z equals 11. 2 plus 3 is 5. Subtract 5 on both sides. And then divide by negative 3. That will give you z equals negative 2. All right, there you go. Okay, one more example. Again, same thing we've been doing. So let's see what we've got. Again, I don't think any of them here are much easier or much harder than any of the others that we need to eliminate. So I am going to I'll pick x this time. I'll eliminate x. But notice this time we have to do a little bit more multiplication to get there, right? Because we don't have any opposites right off the bat. So think if I'm looking to use these first two equations, and I want to eliminate my x, all right? So what I'm going to do is to get this coefficient of 1, I need an opposite. I need opposite of 2, so I need a negative 2. So to get that, I'm going to multiply my entire top equation all the way through by negative 2. So that'll become negative 2x minus 12y minus 6z equals negative 8. That next one, we're going to leave it as it is. And let's add those together. All right, our x's cancel. Awesome, just what we wanted. The y's, that's going to be negative 12 plus 1 is negative 11y. Negative 6z plus 2z is negative 4z. Negative 8 plus 3 is negative 5. All right, there's an equation involving y and involving z. Okay, and then next we are going to use, I'll use the first equation with the third equation, okay? So I'm going to use this equation, and I'm going to use this equation. But, right, I want opposite. So I need opposite of 3. I need opposite here. So I need to multiply that top one this time by negative 3, right? Because now I have a negative 3x up top and a plus 3x at the bottom, and that's going to eliminate the x's when we add those together. All right, so this top one, I'm multiplying it by negative 3. So that's a negative 3x. Multiply this by negative 3, negative 18y. Multiply 3z by negative 3, 9z. Multiply 4 by negative 3, negative 12. Awesome. And then where are we going to go from here? Let's go ahead and write that third equation down. So carry this one down. We got 3x minus 2y plus z equals 0. Go ahead and add them. Negative 20y. What is that? Minus 8z equals negative 12. Oof, we've got a lot of negatives. I'm not a whole big fan of negatives, but sometimes it happens. We got to deal with that. That's okay. So we've got our two equations. I'll underline them in green. Two equations involving y and z. All right, well, the y's look really hard to eliminate here, right? An 11 and a 20, that's going to be a pain to get the multiples of each other. The 4 and the 8 look a lot easier, right? If I multiply this guy by negative 2, this will turn into a plus 8, which is exactly what we want. This will have an opposite with that minus 8. All right, so imagine I'm multiplying this one by negative 2. So 11y, that would be a positive 22. Negative 4z will be a positive 8z. Negative 5 will be a positive 10. Let's drag the other equation over. So we have a minus 20y, minus 8z, negative 12. All right, so then we get 2y equals negative 2. And there we go, y equals negative 1. All right, let's go plug that back in. I'm going to plug it in right here. Again, it doesn't matter which one we plug it into. Just plug it into one of our equations that had two variables, right? That's all that matters, and it's going to let us solve for that z. All right, so I have 22y, so 22 times negative 1 plus 8z equals 10. Negative 22 plus 8z equals 10. Add 22 to both sides. 8z equals 32. And divide by 8. 32 divided by 8. Z is 4. Okay, very last thing. We're going to go back, plug that into one of our originals, and we will find x. I'll do it into the very first one. So I had x plus 6y plus 3z equals 4. All right, so that gives me x plus 6y, so 6 times negative 1, plus 3z, so 3 times 4 equals 4. So that'll be x minus 6 plus 12 equals 4. Negative 6 plus 12 is 6. Subtract 6 on both sides, and there we go. All right, that's it. So nothing really new today, just more examples, more practice. Let me know how I can help. Good luck.